Okay, so let's read this question carefully. It's an average value problem. Water is pumped into a tank at a rate of R of t equals 30 times 1 minus e to the negative 0.16 t gallons per minute, where t is measured in minutes since the pump was turned on. What was the average rate of water flow into the tank during the first 20 minutes? Okay, so we're talking about the first 20 minutes. That means we're talking about the initial time being equal to 0 and the final time being equal to 20. Okay, so that's the time gap that we're looking at, and that's going to constitute our limits of integration. So the average rate of flow from t equals 0 to t equals 20, and it's going to be in minutes, but we'll leave it out for now. Well, what that's equal to is 1 over delta t times the integral from the initial time, so we'll just make it ti, to the final time tf. It's the average value of the rate of flow. So the integral is of the rate of flow. If you want to find the average of the rate of flow, you integrate the rate of flow, and then you divide by the time difference. So the rate of flow here is going to be R of t dt. Okay, so let's fill that in now. And you get 1 over, well, delta t, I mean, we can do that over here if you really need to see it, but delta t is t final minus t initial, which is 20 minus 0, or 20. Okay, but I'm assuming that you know that already. So it's 1 over 20 times the integral from 0 to 20 of R of t, which was 30 times 1 minus e to the negative 0.16 t dt. Okay. Well, that's going to be 1 over 20th. Now, we could integrate this using u substitution, but we're not going to. We're going to use a calculator to integrate this a little bit more quickly. Okay, so let's bring up our calculator, and we are going to have, now mine, remember, is old and looks a little bit different to you. So math 9. Okay, and now we put in the expression that we're going to integrate. So it's 30 times 1 minus e to the negative 0.16 t, or in this case x. And hopefully I've got all that right. Need parentheses for the exponent on the e, and also another parentheses because we opened one after the 30. Okay, so that's the expression we're going to integrate. We're going to tell the calculator that the variable is x, and then the bottom limit is 0, the top limit is 20, and thanks be to God, calculators got a little bit easier, so you don't have the same problem with that parentheses that I do in this slightly older version. Then close the parentheses and let the calculator find out that it's 420. I missed the end of that. Let's bring it back. 420.1429132. 1429132. 1429132. I think that's what it was. If it's not that, you can correct me later. And then just now divide by 20. Okay. So take that and divide it by 20. And you find out that it's 21.007, correct to 3 decimal places. 21.307. We check? No, 007. Okay. 21.007. Now it's an average rate, so it's going to have the same unit as the original rate. So it's going to be gallons per meter. If we go back and read the question. Okay. So it's going to be 21.007 gallons per minute. Okay, so it's an easy enough question to do. You just integrate the expression from the starting time to the final time, and you divide by the difference in time, divide by the time gap. Okay, so hopefully that works out all right for you, and good luck with the questions.